So in this video we're going to continue looking at trends in the periodic table, but this time we're going to explore electronegativity, including general trends and consequences, and we're going to predict and explain trends in chemical reactivity within certain groups, specifically the alkali metals and the halogens. So let's start with the definition of electronegativity. And we've already met this in bonding. Electronegativity is the relative force of attraction that an atom in a molecule has for the shared pair of electrons in a covalent bond. When we're looking at the trends in electronegativity, they are quite similar to that of ionization energy. So as with ionization energy, electronegativity decreases down the group. This is due to an increasing atomic radius. So atomic radius increases as you go down any group, so the outermost electrons become further away from the nucleus, so there is less attraction between the nucleus and the shared pair of electrons. And this is because although the positive charge is increasing, the electrons are being added to new shells each time. If we look then, the second reason is the screening effect. So electrons on inner energy levels shield the electrons on outer energy levels from the positive charge of the nucleus. So again, even though the nuclear charge increases, this increase is cancelled out by shielding. So the electrons on this outer shell here, the positive charge is shielded by the electrons on the inner shell. So electronegativity increases as you go across the periods, and this is due to an increase in effective nuclear charge. The number of protons increases as you go from left to right, so there is more attraction between the outer electrons and the nucleus. So the electrons involved in the bonding are being more strongly attracted to the nucleus. We then have a decreasing atomic radius, and that's because the electrons in the outermost energy levels are becoming closer to the nucleus, so there is a greater attraction between the outer electrons and the nucleus. So the last thing we want to look at in this topic is we want to look at trends within groups. And chemical properties of elements are largely determined by the number of electrons in the outermost shell. So therefore, elements in groups will have specific trends because elements in the same group have the same number of outer electrons. So this slide here is just a summary of groups that you would have met at junior cycle. So you've got the alkali metals, the alkaline earth metals, the halogens, and the noble gases. So it's worthwhile having a read through each of these just to refresh your memory from junior cycle. In particular, we're going to look at the alkali metals and the halogens in particular. So let's start with the alkali metals. The trends with the alkali metals. Firstly, alkali metals are very reactive as they all have low ionization energy values. And that is because they all have one electron in their outer shell. They're very reactive and none of them occur freely in nature. They readily form ionic compounds by losing a single electron due to low electronegativity and first ionization energy, as we've said already. The reactivity of the alkali metals increases down the group due to increasing atomic radius and screening effect. So as you go down the group of the alkali metals, you get more and more shells. So the atomic radius is increasing, and the outermost electrons are becoming further away from the nucleus, and there is then a screening effect of the inner electrons. Alkali metals react with oxygen to produce oxides. So an example of that is potassium and oxygen producing potassium oxide. And here you would start with K and O2 to give you K2O, and the 2.5 comes from balancing. And this is why alkali metals are stored under oil, because they can produce harmful oxides. They can also react with water to form hydroxides, and hydrogen gas is given off, and this is another reason why they're stored under oil. So here's a sample. Sodium will react with water to produce sodium hydroxide and hydrogen gas. So you've got your sodium Na reacting with your H2O to produce NaOH and hydrogen gas. Next, if we look at the trends in reactivity of the halogens are the most electronegative elements on the periodic table. And electronegativity decreases as you go down the group. We know that from earlier. The halogens are quite reactive as they have such an attraction for electrons. So they all have 7 electrons in their outer shell. So they just need one more to have their full octet. And similarly to the alkali metals, they do not exist freely in nature. Reactivity of the halogens decreases as you go down the group due to decreasing electronegativity values. Halogens tend to remove electrons from oxidizing agents, and this is explored in the electrochemical series in oxidation and reduction. So if we take an example, chlorine gas is bubbled through bromine ions. The chlorine will take electrons from the bromine, showing that the electronegativity of chlorine is greater than that of bromine. So if we look at our equation, we have Cl2, chlorine gas, with our bromide ion. It produces chlorine ions and bromine gas. So if we take a look at bromine water, when it reacts with iodide ions, iodine is formed as the bromine atoms take electrons from the iodide ions, showing us that bromine is more electronegative than iodine. So as we can see here, we have the bromine gas reacting with the 2 iodide ions to give us 2 bromide ions and iodine itself. So the rule is that the more electronegative halogen displaces the less reactive halogen from a solution of its ions. So for the halogens, a lot of energy is required to separate the atoms from each other, and this causes an increase in boiling points as we go down between individual molecules increases as you go down the group due to the increasing size of the atoms in the molecule. So if we look, fluorine has a boiling point of minus 188 degrees, chlorine has one of minus 34.7, bromine has one of 58.8, and iodine has one of 184 degrees Celsius. So this slide here summarizes everything that we've learned from the trends in this chapter. So electronegativity increases as you go from left to right, as does ionization energy, but the atomic radius decreases. As you go down the periodic table, atomic radius increases, while ionization energy decreases, as does electronegativity. So that's it for this video. Read over the learning intentions to make sure you understand everything we've gone through.